All right. So again, our voices need to go ahead and be off. Thank you. All right. So today we're talking about proportional relationships when we're talking about graphs. So if you recall, all week we've been talking about proportionality. So now we're moving into what the graph looks like. So to be proportional on a graph, there are a few things that we need to look for, and one of them is that the line will go through the center point. The center point is called the origin, and that's where 0, 0 dwells. The rate of change will be equal to the constant of the proportionality, which is k, which we know that to be y over x. The equation of the line will be, we know it's y equals mx, because the plus b will be plus 0, because again, is going through the origin, but we know to look at it as y equals kx. So that's the two ways that we can see that. So even here, if we wanted to determine what is the rate of change here, what we can do, because it's proportional, we can go to the y and the x. So we need to get a point. We can't officially use 0, 0, because 0, 0 is implied. And what does that mean? That means that if it's already implied, we can't really use that. But we can use any other point on here. So for example, if I was going to use here, which is 0.22. So if I'm using 2, 2 as my point through a proportional graph, remember y over x is what we use to find out what our k is. So that's 2 over 2. So our rate of change will be 1. So what does that look like as an equation? Y equals x. Sir? Yes, you can, but don't let me see you do that again. So that's what that will look like. So here, an ATV travels 25 miles per hour, where x is the number of hours and y is the number of total miles. So they tell us what the x and the y axis is. Let me back up, because if we're not aware of which axis is axis, we need to know that this is always going to be your x axis and this is always going to be your y axis. So if they tell me that my x is the number of hours, so down here we're talking about hours, and then my y axis is total miles. So over here the title will be total miles. So if I know that I'm going 25 miles each hour, each lets me know we're talking about multiplying. So it's talking about an x here. So this is where my x will be. So each 1 hour, I'm going 25 miles. So I know that'll be my point there. Then you can think about what will happen, because you can even make a table for yourself to say what will happen for a couple of them. So I know that when it's 1 hour, it's 25. If it's 2 hours, it's 50. So at 2, I'm going to put mine at 50. So when we go to draw the line, it goes through the 0, 0. That's implied because it's proportional. So my rate of change, even if I use the 1 and 25, because that's the decimal, that's the one we have there, x will be 1, 25 will be our y. So my rate of change, which is y over x, is 25 over 1. So my rate of change is just 25. My equation is y equals 25x. So here, the number of cars, which is x. So here I know these are my cars, is proportional to the number of wheels, which is y. Here's my number of wheels, is y. So now we have to find the rate of change of that. How many wheels does one car have? Did someone say 2? Oh. So a car has 4 wheels. So at 1, I know I'm going to say 4. So even if I had a table, I can say for one car, there are 4 wheels. For 2 cars, there are 8 wheels. So then I'm going to go 2, and then I'm going to go to 8. I need at least 2 points to make a line. So remember, if I know that one car is 4 wheels, I have enough to be able to determine my rate of change because this is proportional. So again, rate of change is y over x. So that's 4 over 1. So it's 4. So my equation is y equals 4x. Sandra plots the points 0, 0, and 5, 10 on a graph to represent a proportional relationship. Find the rate of change. So we can make our own graph if we need to, but do we really need our own graph? We don't. This is how I know this is proportional because one of her points is 0, 0. This is the origin. Remember, we said that if it goes through the origin, then I know for sure this is a proportional graph. So that means I can use the second point that she have to do what we know, which is y over x. If this is her x and this is her y, that's 10 over 5. 10 over 5 is just 2. So my rate of change will be 2. And my equation will be y equals 2x. I'm turning the page. Does anyone have questions on that so far? Because I don't want anyone to be confused. This is your time to speak up, and we can address any issues or questions you might have. Okay, some of these I'm not going to go over because, again, we're doing the very same thing that we've been doing. But let me look. It was one I wanted to look at. Okay, let's look at number 5. We're going to do 5 and 6, and then you guys will do 7 for yourself. All right, so number 5, a farmer plows his cornfield. The relationship between X, which is the hours driving the plow, and Y, the number of hours, the number of rows corn plowed, is shown in the graph to the right. So here's our graph. What does the point 0, 0 represent? It's the origin, yes, but what does it mean in this scenario? What does it mean at 0, 0 for the time and the number of corn rows? What does 0, 0 mean? How much time did he spend? Yes, but we want to know about in this scenario because we have to be able to interpret what's happening in that very scenario, and that'll help you to still grab hold of what's happening. So think about it like this. If at 0, that means that in time he plowed 0 rows of corn. Corn was plowed in 0 hours. That's all that means. The point of it asking you what does it represent is because it wants you to be able to read a graph. Because if we can read a graph, then we know that 0 time was spent, or 0 time was spent to row 0 corn. Like, it doesn't matter if you just take it verbatim and just say like 0 time or 0 time spent to make 0 rows of corn. When it's asking you about what does it represent, they want you to use whatever number and use the titles of that row to make it make sense so that you will know. Because what does it mean at 4? If at 4, what does that mean at 4 and 60? Exactly. That's exactly what it means, and we have to know how to do that. All right, so choose an ordered pair to find the constant rate of proportionality. So we already said 4 and 60. So what will be our rate of change here? What will be our rate of change here? 15, because you did 60 divided by 4, because that's y over x, and you got 15. And so our equation then will be y equals 15x. Great job. All right. Can we have someone do number 6 for us, please? It says Patricia is asked to determine if the statements below represent the graph. Check all that apply. So let's have someone do this one first. Where did we leave off last night? Rania, the equation y equals 2.5 or 2.5x represents the situation. Is that true for here? Okay, tell me why you say no. Okay, so pause. You said 1. So right here at 1 where it's hitting the line, you're saying this is 1, 5. What are you saying it is? So 2 equals 5. So you want to use that point? Okay, so if we use 2 is 5, how do I find out the rate of change with that? What fraction is that? So 5 divided by 2, which is what? 2.5. So is this true? So this is true, because that's what we'll get. All right. So Micah, the cost of parking for 8 hours is $20. Is that true? How do you know? Great job. Thank you. Amina, the cost for parking for 10 hours of parking is $4. Is that true? Hmm? You said no? Why? Because what? Okay, so how much will parking be for 10 hours? I didn't hear you, hon. 25. Do we agree? Yes, that's right. Because if our equation is y equals 2.5 and I plug in 10, I'm going to get $25. Great job. So that's not right. Justice, the graph will contain the coordinates 1230. Is that true? Why do you say no? What can we do with this coordinate, Justice, to determine if it does the same thing, if it's the same rate of change? Huh? Right. So what would that look like if I divide the y by the x? I'm at 30 over 12. And what do I get? How many 12s will go into 30? So we know 2 will go into 24. And then I'm left with 6 more. And so if I like use a decimal, that'll give me 60. So how many 12s are going to 60? 5. So will that still be the same thing? So that means that this coordinate must be included because they share the same rate of change. So this is included. Great job. All right. So that's the end portion of these notes. The best way to really deal with this is to do practice. If you feel like you need extra support, this is the practice that I want you to go ahead and move to. If you feel like, okay, I actually got it, my notes make sense, this makes sense, start on the homework page instead. But if you need this, I'm going to post the answers to the backboard of these questions. This is additional practice for you to help yourself. Other than that, then you can move to the homework page.